Okay, students. So let's get started with the topical past papers of theory for the chapter of work, energy, power. So let's see the first question. A child, a child's toy consists of a flexible track and a model car. Okay. Figure 2.1 shows a diagram of the toy. Okay. The child first holds the car stationary at point A. So that means at this point A, if your car is stationary, that means the kinetic energy at point A will be equal to 0 joules. Since it is held stationary at A, the velocity at A will be 0. Okay. Point A is a distance of 0.45 meter above the horizontal sections of the track BC and FG. The mass of the car is this. The child then releases the car which travel towards point B. Okay. Both air resistance and friction between the car are negligible. The gravitational field strength is 10. Okay. Calculate the change in gravitational potential energy of the car as it travels from A to B. Okay. We have to calculate the change in gravitational potential energy as it travels from A to B. What will be the change in gravitational potential energy? Mass G into change in height. As you move from A to B, what is the change in height? 0.45 meter. What is your mass? 0.12. What is your gravitational field strength? 10. So just plug in the values. 0.12 multiplied by 10 multiplied by change in height, that is 0.45. What will your answer come out to be? 0.12 into 10 into 0.45. This equals to 0.54 joules. Okay. Calculate the speed of the car when it reaches B. We have to calculate the speed of the car when it reaches B. So what can we say? Gravitational potential energy at A is equals to the kinetic energy at B. The gravitational potential energy we are already given 0.54 is equals to the kinetic energy 1 upon 2. What is mass? Mass is 0.12. Okay. Let's place mass as 0.12 into the velocity at B square. 0.54 into 2 divided by 0.12. Okay, take an under root here. This comes out to be 3. The velocity at B comes out to be 3 ms minus 1. Okay. Let's see part C. After releasing it, the child expects the car to follow the track along the route A, B, C, D, E, F, G. Okay. After the car is released, the child expects the car to follow this route. Okay. Okay. What is happening actually? Let's see. Explain in terms of energy why the car does not go past D. Why will the car does not go past D, which is also 0.45 meter along above the horizontal track? Okay. So can you see at A, your entire energy is consisting of gravitational potential energy. However, when you arrive at D, some of your energy is kinetic energy and some of your energy is gotten divided into gravitational potential energy. Let's say you had a gravitational potential energy of 0.54, I guess, right? Yeah, 0.54 at A. When you come at point D, some of the 0.54 joules of energy gets converted into kinetic energy and some remains as gravitational potential energy. Hence, it does not go past D. You can write it here. Explain in terms of energy why the car does not go past D, which is also 0.45 meter above the horizontal track. Why? Because at D, some of the energy has gotten converted into, has gotten converted into kinetic energy and hence it cannot go past D. Or you can say the gravitational potential energy at D is less. At D is less. Simple. It's a one marker question. I hope this answer will suffice this. Immediately after being released at A, the car travels from B to C and then to D. Describe the motion of the car after it reaches D. Okay, once you have reached D, what will happen? It will not go past D. It will come back to C and again to A. So from D to C to A, this will be your journey. Okay. Let's move on to the next question. Figure 2.1 shows a long cardboard tube sealed at both ends, which contain many small pieces of metal. Okay. The tube is turned vertically so that the pieces of metal fall from one end to the other. The temperature of the pieces increase as a result of the fall. Okay. So the temperature of these pieces increase as a result of the fall. Okay. During the fall, the gravitational potential energy of the metal pieces is transformed to other forms of energy. State two forms of energy to which gravitational potential energy is transferred. Okay. So as you are falling downward, gravitational potential energy during the fall, gravitational potential energy of the pieces is transformed to what? Thermal energy, first of all. Why? Because the temperature is increasing. And as you are rotating, the gravitational potential energy gets transferred into kinetic energy as these particles start to gain velocity. Simple as that. Let's further move ahead. The pieces fall an average distance of 1.2 meters during one turn. The total mass of the metal is this. Calculate the loss in gravitational potential energy of the pieces as they fall once the gravitational potential energy G is 10. Okay. So we have to calculate the loss in gravitational potential energy mgh. What is the mass? 0.15 kg. What is g? 10. What is the height? 1.2. Can you calculate the gravitational potential energy? Yes. 0.15 into 10 into 1.2. This comes out to be 1.8 joules of energy. Okay. The student turns the tube quickly after the small metal piece have fallen from one end to the other 80 times. So if you are rotating 80 times, what will be your energy change in gravitational potential energy? 80 times 1.8 will be your total energy, or you can say Q. So multiply it with 80, this comes out to be 144 joules. Okay. If you rotate the tube 80 times, the total energy will be 144 joules. This causes a temperature rise of 7 degrees centigrade. Determine the specific heat capacity of metal. So we know Q is equals to mc delta theta. Q is 144. What is your mass? Your mass, I guess, was 0.15. Let me check. Yeah, 0.1. It is 150 grams, so it will become 0.15 kg. Okay. So let's place it here 0.15 kg. Your change in temperature is 7. Your specific heat capacity is C. 144 divided by 0.15 into 7 is your specific heat capacity. Let's answer this. 0.15 into 7. This gives you a value of 137 as your heat capacity. What will be the specific heat capacity? What will be the units of a specific heat capacity? Joules per kilogram per degree centigrade is your specific heat capacity. Let's further move ahead. The student repeats the experiment, turning the tube more slowly. Suggest why a different temperature increase is obtained, because if you turn the tube more slowly, there is more heat losses. More heat losses. Simple. Let's move on to question number 3. Figure 2.1 shows a wind turbine. Okay. The wind blows directly towards the turbine with a speed of this. In 1 second, there is this mass of air passing through the circular area. Calculate the kinetic energy of the mass of air. 1 upon 2 into mass, that is 60,000, into the velocity, that is 12 ka square. This comes out to be what? 60,000 into 12 square. Okay. Divided by 2. This gives you a value of 4.32 into 10 raised to the power of 6 joules of kinetic energy is passing through these blades. A wind turbine releases no carbon dioxide into the atmosphere while generating electricity compared with a coal fired power station. This is an advantage of using a wind turbine. State one reason why why it is important to reduce the amount of carbon dioxide produced. Why? Because it causes global warming. Carbon dioxide causes global warming, hence, it is imperative to reduce the amount of carbon dioxide produced. State one advantage of using a coal fired power station over a wind turbine. So that's pretty easy. The wind is not reliable The wind speed, you might say. The wind speed is not reliable and can change and can change uh, and can change according to weather or time of the day. According to weather or time of the day. Hence, power produced is unreliable. Hence, amount of power produced is unreliable. Simple as that. Is unreliable. Simple as that. Let's further move on to the next one. A coal fired power station releases 0.96 kgs of carbon dioxide when it generates 1 kilowatt hour of electrical energy. Define kilowatt hour. When 1 kilowatt power is supplied for 1 hour, that is known as kilowatt hour. Okay, let's further move ahead. Calculate the mass of carbon dioxide saved when the wind turbine has a power output of 20 kilowatts, which operates for 12 hours. Okay, so if your power is 2000 kilowatts and the time is 12 hours, can you calculate the energy? Yes, energy is equals to power into time. 2000 into 12, this comes out to be what? 2000 into 12. This gives you an answer of 24,000 kilowatt hours. Okay. And each kilowatt hour saves 0.96 kg of carbon dioxide. So 24,000 kilowatt hour will save how much carbon dioxide? 0.96. This comes out to be 23040 kg of carbon dioxide. Simple as that. Wind energy is a form of renewable energy. State the name of one other form of renewable energy. Maybe tidal. You can write tidal here. There are multiple options. I am writing tidal. You can also write hydroelectric. So, yeah, there are many options that you can write here. Let's further move ahead. A large spring is stretched by an athlete to increase the strength of his arms. Okay. The athlete extends the spring as shown in figure 3.1 and then releases it gently. He extends and releases the spring several times during a period of 60 seconds. Okay. State the form of energy in the stretched spring and the form of energy stored in the muscle of the athlete. The form of energy in the spring is what? Elastic potential energy. Elastic potential energy. And what is the form of energy stored in the muscles? Chemical energy. Simple as that. Suggest what happen if he extends the spring beyond the limit of proportionality. What will happen? The spring becomes easier to stretch. The spring becomes easier to stretch. Easier to stretch. Simple as that. Let's move on to part C. During one extension of the spring, the length increases from 70 to 93 centimeter. Okay. The average force exerted by the athlete is 400 Newton. Okay. Calculate the work done by the athlete in one extension. Work done is equals to what? Force into distance. Your force is 400 Newton. Your distance traveled is what? 93 minus 70. That is 23 centimeter divided by 100. This becomes 1, this becomes 4. Why have I divided 23 by 100? Because I wanted to convert centimeters into meters. 4 into 23, this becomes 92 joules as your work done. Describe how the athlete can use the value obtained in 1 to determine his average power during 60 seconds. Okay. What can the athlete do? Athlete can count number of times he stretches the spring in 1 second. Oh, sorry, in 60 seconds. Stretches the spring in 60 seconds. Then what can he do? He can calculate power by doing what? Let's say these number of time he stretches the spring is given a constant of n. N multiplied by the work done, calculate in A part 1 divided by the time, that is 60 seconds, will give The athlete his average power. Simple as that. Let's further move ahead. Okay, let's see this. Wind energy is a renewable source of energy. A wind turbine and a generator convert energy in wind to electrical energy in a generator. Figure 9.1 shows some wind turbines. Okay, state what is meant by a renewable energy source. It is an infinite, or you can say replaceable energy source. Simple as that. One marker questions are literally really easy. State the name of one other renewable energy source: tidal, hydroelectric, can come here. Some methods of generating electricity cause much more global warming than wind energy. State one method of generating electricity that causes a large amount of global warming: coal fired power station. Coal fired power station produces a lot of carbon emissions. Okay. Describe and outline how the method you have chosen causes a significant amount of global warming. Because coal fired power stations, power stations produce what? Produce carbon dioxide, produce carbon dioxide as the byproduct, as the byproduct, which causes global warming, which causes global warming. Simple as that, nothing complicated here. I hope so you understand this. Let's further move on to the next question. During a 30-minute period, a mass of this air enters the turbine with the speed of this. Calculate the kinetic energy of the air that enters the turbine during the 30 minutes. 1 upon 2 into the mass, that is 4.2 into 10 is the power of 7, into the velocity square, that is 15 square. 4.2 into 10 is the power of 7 into 15 square divided by 2. This comes out to be what? 4.725 into 10 raised to the power of 9 joules. Okay. This will become what? 4.73 into 10 raised to the power of 9 joules. Simple. If I put it till three significant figures. The electrical power output of the generator connected to the turbine is this. Calculate the electrical energy. Okay. So we are given the power, we are given the time, we have to calculate energy. Energy is equals to power into time. Power is 8.4 into 10 raised to the power of 5 multiplied by the time, that is 30 minutes, into the amount of seconds. Always remember we convert time into seconds. So 8.4 into 10 raised to the power of 5. 1 second. 10 raised to the power of 5 into 30 into 60. This becomes 1.512. 1.512 into 10 raised to the power of 9 joules. Yeah. Calculate the efficiency of the turbine and the generator in converting the kinetic energy of the air to electrical energy. Okay. So basically, what is this? This is the energy input. Sorry, this is the energy output. This is the energy output. And this is what? This is the energy input from the air. Can I calculate the efficiency? Yes. Efficiency is the formula of what? Efficiency is given the formula of energy, or let's write it completely. Efficiency is given the formula of useful energy output divided by the total energy input. So what is your total energy input? 4.73 into 10 raised to the power of 9. What is your energy output, or you can say useful energy output? 1.512 into 10 raised to the power of 9. This and this gets cancelled out. 1.512 divided by 4.73. This gives you an efficiency answer of 0.32. Simple. Let's further move ahead. The generator contains a coil that rotates the poles of a magnet. The coil rotates 50 times in 1 second. So this is your frequency. Okay. And produces an alternating voltage with a maximum value of this. This is your maximum value of voltage. On the grid in figure 9.2, sketch a voltage versus time graph showing the output voltage. Okay. So this is your frequency. Can you calculate the time period? Time period is 1 over frequency, 1 over 50. Time period comes out to be 0.02 seconds. So that means one wave will get completed from 0 to 0.02 seconds. Maximum voltage is 500. So maybe your graph will look something along these lines. Something along these lines. Obviously, you can draw another oscillation as well. Somewhere here. And yeah, like this. Like, oh, actually, I'm really bad at drawing. So please pardon me for that. This has been a childhood issue. So yeah, this is your second oscillation. Let's move on to part 2. The output voltage from the generator is stepped up by a transformer. The electrical energy then passes along a transmission line to a distant house. Okay. Explain why a high voltage is used for the transmission of electricity. A high voltage ensures what? A high voltage ensures low current. And if you have a low current, what is the formula of power losses? Power losses is equals to I square R. If your current reduces, what happens? Your power losses reduces. Power loss reduces, that improves efficiency. Improves efficiency. Simple as that. Okay, so let's see the next part of this question. A transformer is used to connect the transmission line to the house. So basically, why is a transformer connected between the transmission line and the house? So a step down transformer is connected actually between the transmission line and the house. Why? To bring the voltage back to the normal working voltage, that is 240 volts. A step down transformer transformer is connected is connected to bring the voltage value to 240 volts. Simple as that. Let's move on to the next question. Figure 2.1 shows an electric motor lifting a board. Okay. The weight of load is 5 Newton, is raised through a vertical height of this. This is your weight, this is your vertical height. The efficiency of the electrical motor is this. Calculate the increase in gravitational potential energy. How will you calculate the increase in gravitational potential energy? That is equals to mgh. Your mg is given 5 Newton, your height is given 3.5. That comes out to be what? 5 into 3.5. This comes out to be 17.5 joules of energy. State the formula that relates efficiency, energy input, and energy output. Very easy. Efficiency is equals to useful energy output divided by what? Divided by energy input. Okay. Calculate the energy input to the motor. Very, very easy. Your efficiency is 65%. So place a 0.65 here. Your useful energy output is 17.5 divided by energy input. Can you calculate the energy input? Yeah. Let's take energy input to the other side. Energy input comes out to be what? Energy input is equals to 17.5 divided by 0.65. 0.65 divide karo, this comes out to be 26.9. This comes out to be 26.9 joules as your energy input. Suggest one reason why the efficiency of the motor is less than 1 due to due to friction, due to frictional forces, due to friction forces. Simple. Let's further move ahead. Or you can also write due to heat losses. There are many reasons here. Due to heat losses. Due to heat losses. Let's move on to the next question. Figure 2.2 shows a rider on an electrical scooter. The scooter contains a battery and a motor to drive the back wheel. State the name of energy stored in the battery. What is the name of energy stored in the battery? Chemical energy. Okay. Describe in terms of work done the stages of energy transfer from the energy stored in the battery to the kinetic energy of the scooter. So basically, what is happening? Chemical energy, first of all, gets converted into what? Chemical energy, first of all, gets converted into what? Electrical energy. And then electrical energy gets converted into what? mechanical energy, or you can say mechanical energy or kinetic energy. Yeah, let's further move ahead. The total mass of the scooter is 70 kg. Calculate the total kinetic energy of the rider and the scooter when the scooter has a speed of 4 ms minus 1. So 1 upon 2 into the mass, that is 70, into the velocity, that is 4 square. So 70 into 16 divided by 2, this gives you a value of 560 joules of kinetic energy. The battery is marked with an energy capacity of 0.35 kilowatt hour. State what is meant by kilowatt hour. A power of 1 kilowatt hour, a power of 1 kilowatt acting for 1 hour, for 1 hour, or being supplied for 1 hour. A power of 1 kilowatt supplied for 1 hour. Simple as that. Let's further move ahead. The scooter stops working when the battery is totally discharged. This means that there is no more energy stored in the battery. The battery is then recharged using a 70 volts power supply. Calculate the time taken to fully recharge the battery. We know power is equals to energy over time. Let's make time the subject. Time is equals to energy over power. What was your energy? 0.35 kilowatt hour. Where did I get it from? Here. What will be my power? My power will be, if I convert this into kilowatts, so 70 divided by 1000, this becomes 0.07 kilowatt. So divided 0.07, your time comes out to be 5 hours is your answer. Simple as that, nothing complicated. Let's move on to the next question. The foundations that support a building are long concrete cylinders that are pointed at one end. A pile driver is a machine that forces the pointed concrete cylinders into the ground. Figure 2.1 shows a pile driver. Okay. A heavy block of mass, this 2.9 into 10 is to the power of 4 kg, is lifted into the air and then dropped onto the top of a concrete cylinder. This forces the cylinder into the ground. Okay, very, very easy. So let's see this. Figure 2.2 shows the heavy block. Okay. The block is 2 meter tall and a cross sectional area of 1.8 meters square. Okay. Calculate the density of the material. You have to calculate the density of the material. The density of the material is mass over volume. What is your mass? What is your mass? 2.9 into 10 raised to the power of 4. 2.9 into 10 raised to the power of 4. What is your volume? Area, that is 1.8, into the height, that is 2. Can you calculate the density? Yeah, that's pretty easy. 2.9 into 10 raised to the power of 4 divided by 2 into 1.8. This comes out to be 8055. 8055. If I convert it till three significant figures, 8060 kg m minus 3. Simple as that. The pile driver lifts the block from the top of a concrete cylinder through a height of this. The gravitational field strength is this. Calculate the gravitational potential energy gain. So the gain in gravitational potential energy will be what? Mass g into change in height. What is your mass? Are we given the mass? 1 second. Yeah, we are given the mass. 2.9 into 10 raised to the power of 4. Are we given the value of g? Yes, that is 10. Are we given the value of height? That is 0.8. Can we calculate this answer? 2.9 into 10 raised to the power of 4 multiplied by 10 multiplied by zero point 0.8. This gives you a value of what? 1 second. This gives you a value of 2.32 into 10 raised to the power of 5 joules as your change in gravitational potential energy. Let's further move ahead. The block is then dropped from rest onto the top of the concrete cylinder. Calculate the speed of the block just before it hits the concrete cylinder. So what is happening? Initially the block is rest. So all the energy will be gravitational potential energy. This gravitational potential energy gets converted into kinetic energy. Do you know the value of gravitational potential energy initially? Yes, 2.32 into 10 raised to the power of 5 is equals to the kinetic energy 1 upon 2 into the mass. What is mass? 2.9 into 10 raised to the power of 4 into the velocity at the end square. So let's calculate this, let's divide this answer by 2.9 into 10 raised to the power of 4 and take an under root. Your velocity comes out to be 4. Velocity is 4 ms minus. Oh, what am I doing? 4 ms minus 1 is your velocity. Simple as that. Let's further move ahead. The total mass of a wheelbarrow and its load is 90 kg. A worker pushes the wheelbarrow and loads up a plank 2 meter onto a platform as shown in figure 2.1. The platform is at a height of 0.6 meters. Simple. Okay. The worker exerts a force of 290 on the wheelbarrow in the direction in which the wheelbarrow moves. Okay. The gravitational field strength is 10. Okay. Calculate the gravitational potential energy gained by the wheelbarrow and its load. Okay. You have to calculate the gravitational potential energy gained by the wheelbarrow and its load. What is the mass of the wheelbarrow and its load? 90 kg. Okay, so the gravitational potential energy gain will be equal to what? mgh. Your mass is 90, gravitational potential energy is 10. What is your height gain? 0 0.6. What does your gravitational potential energy come out to be? 90 into 10 into zero point 0.6. This comes out to be 540 joules. Simple. The worker pushes the wheelbarrow 2 meters along the plank. Calculate the work done on the wheelbarrow by the worker. Okay, we have to calculate the work done on the wheelbarrow by the worker. The worker applies the force of 290, travels a distance of 2 meters. What will be the total work done? Work done will be equal to 290 into 2. This comes out to be 580 joules. Okay. Suggest one reason why the answer to part A2 is not equal to part A1. Okay. Why are these two answers different? Because there might be some frictional forces between the tires and the track. So you can say frictional forces between the tire and the track. Frictional forces between tire and the track. Between the tire of the wheelbarrow, between the tire of wheelbarrow and the track. Between the tire of the wheelbarrow and the track. Simple as that. And the track. The worker finds that walking up the plank, pushing the wheelbarrow, is even more inefficient than the answers in A. Suggest what is meant by efficiency. Very, very easy question. Useful energy output, useful energy output divided by what? Total energy input. Divided by total energy input. Simple as that. Suggest one reason why this method of lifting the load onto the platform is so inefficient. Okay, why is this method of lifting the wheelbarrow up the platform is so inefficient? Because we haven't considered the mass of the person as well. See, we have just considered the gain in the gravitational potential energy of the wheelbarrow and its contents. We haven't considered that the mass, the person, is also going up the platform. That will also require some work done. So you can write here the mass or weight of the person is assumed to be negligible. To be negligible. However, if we consider the mass of the person or weight of the person, then this process will get even more inefficient, because then we will also have to do some work done to move this person up the platform. Let's move on to the next question. During a game of cricket, a player hits the ball with a bat. The ball then travels vertically upwards as shown in figure 8.1. Okay. The speed of the ball as it leaves the bat is this. The mass is this. What is meant by mass? We have already done that several times in this past paper series. State the name of a measuring instrument that is used to measure mass. Maybe electronic balance. Yeah, that will work perfectly fine. Electronic balance, or you can say beam balance. That also works perfectly fine. Let's further move ahead. Calculate the kinetic energy of the ball 1 upon 2 into what is the mass. Mass is 0.16 into the velocity, that is 8.7 square. 8.7 square. So 8.7 square into 0.16 divided by 2. This gives you an answer of what? kinetic energy is 6.05 joules. Let's further move ahead. Figure 8.2 is the velocity time graph for the ball. Okay. Figure 8.2 shows that immediately after being hit, the ball has a negative acceleration. State the name given to negative acceleration, that is deceleration. Simple as that. State how the graph shows that the ball has a negative acceleration, basically negative gradient. Negative gradient. Simple. Negative gradient line, you can say that. Use figure 8.2 to determine the time taken at which the ball stops moving upwards. So the ball will stop moving upward when the velocity becomes zero. So the velocity is becoming zero at this point. Yeah, this point. 0.88 seconds. Yeah, 0.88 seconds is your answer. So the ball stops moving upwards at 0.88 seconds. That is the point where the velocity becomes zero or the ball comes to an instantaneous rest. The distance traveled before the ball stops moving upwards. So we will calculate the area of this triangle. The base is 0.88. What will be your height? Let me zoom in a bit. This is your height. This will be uh, 8.4, 8.8. So this will be 8.8 as well. Okay. So let's calculate this 0.88 into 8.8 divided by 2. This gives you an answer of 3.8. So 3.87 meters is your distance traveled. So you can copy this working in the space below as well. Let me write down the answer here. Let me zoom out a bit. 3.87 meters. Okay. Suggest why the graph in figure 8.2 is almost vertical when time is 1.84 seconds. Why is this almost vertical? Because the ball hits the ground. Ball hits the ground. Ball hits the ground. Simple. Let's see part 4. Figure 8.2 shows that the ball remains stationary after time 1.84 second. Describe the energy changes that is occurring at 1.84 seconds. Okay. So basically what is happening? Kinetic energy is getting converted into thermal energy, or you can say kinetic energy is getting converted into what? Kinetic energy is getting converted into internal energy. So these are the two energy changes that are happening here. Let's further move ahead. For this ball moving in the way shown, the effect of air resistance is negligible. Okay. When a ball is much smaller mass is hit vertically upwards at the same speed, but with a smaller mass, air resistance produce a noticeable effect on the motion. Okay. Suggest two ways in which the velocity time graph for the ball with a smaller mass differs from figure 8.2. First of all, a smaller distance will be traveled. A smaller distance traveled. A smaller distance traveled. And secondly, what will happen? The graph will be a curve. The graph will be a curve, or you can say the velocity time graph will be non uniform. The velocity time graph will be non uniform. Simple as that. This marks the end of work, energy, power, past papers. If you have any questions, you can ask me.